Now, what we want to do is to go back to the problem that we solved and walk through the steps to see how we are changing things to use PyTorch to do to take the gradients for us and to rewrite that program with PyTorch. All right, and that's the last thing we will do today together, and then we will talk about other stuff. All right, is this big enough? Yeah, it's huge. And by the way, do you still see it? Everything good? All right. By the way, these notebooks are nice, and they are always functioning and looking good because Willie spent a lot of time checking them and testing and putting them together. So thanks to Willie for doing that for us. All right. So here, what changes here is that we need to import torch, and then we define our function. So here, when we say W, we say requires grad, so that it calculates the gradient for us. Nothing changes here. We define the forward function. These are now you're very familiar with all of these, right? Nothing changes there. And so what actually changed is where we want to compute the derivative. We just say w.grad, and that computes this contains the gradient for me, and this is an object. So dot data is where we are storing the value of the gradient with respect to W. So you remember this loop, the do loop, the for loop? We do the same thing, and then we say, so we compute the loss, and we say L dot backward. That's where the backpropagation happens in PyTorch. And then when we want to update our W, we just say W. Now W is a tensor, so we update the data part of it. So W.data is W.data minus learning rate times the gradient.data. Done. This is all you need to know about doing the backpropagation and taking gradients, and then we zero it out at the end of every loop. Now, what? To start fresh next time. Yes. All right. So so that's it. Now let's look at something more complicated. If we change the function to have two variables to have two parameters that we need to learn, we saw that it can quickly get complicated. Now, in this formalism, you can see we are now starting with a random W and a random B, right? So this starts from a random point, and then it learns the value of the function to fit this. And in the parameter space, what we actually are doing is so this is the loss function. The loss function is now a surface because we have two dimensions. We have W and B, And then we start with from a random point, and we roll down to the bottom of the, yes.
So our local minimum is the same as our global minimum in this example-specific data?
Yes. Yeah. Here we only have one minimum, and that's global. We can have, in real life, you can have many different minima. And, you can have beautiful landscapes in 6 million dimensions, and you cannot even visualize that. So this is clear. We know what we are doing here. Yes? And the solution is so we compute the loss, we do the backprop, and then we update W, we update B with the respective gradients. And then we plot it, and we see yes.
Did you change the loss function?
No, the loss function is the same. Well, we changed the function, but the loss function is still the loss function. Oh, here. The loss function is still y predicted y minus observed y squared. That's it. All right. Now, so this is it. Let me see how much time we have. I want to give you at least 10 minutes to just to take a look at it, play with it, run it once for yourself, make sure that you're comfortable with it, because this is our last hands-on. So go do it, and then we will come back. I will tell you about a couple different related topics, and then we will stop. And then we'll stop. We will discuss what is next, what to do next. We have come all the way together up to here, where to go from here, and then Amir will tell you about some interesting directions and things to do next. And by popular demand, we are going to have Sia explain the backprop to you, as he was doing. What you were explaining right now.
Answer questions. You guys have any?
I have a lot.
Okay, come here.
She has a lot of questions. Okay, where is that thumb thingy? How do you scroll?
Click.
This?
No, yeah.
Oh.
Yeah. The other one?
Okay, what's your question?
So I understand like what we're doing in Spirit. I find it really hard to understand how Torch interacts with Python. I don't know if that's the right way to put it, but I'm getting confused on how we write stuff. So we first compute. We have a function that depends on, so we have x and y that are our data points, and then we have a variable that is w. And the whole goal of this exercise is to find the best fit for w. So we assign a torch variable. Now a torch variable is w, right? And we want to do this back propagation or these gradients with respect to w.
Okay.
So when we define the loss function, we call it L, and then we say L dot backward, and that allegedly computes the gradient of the loss function.
Computes the gradient of the loss function with respect to
The variable.
all your variables that you have in
Yeah.
your function.
In this case, it's just W.
So maybe you can repeat the whole question.
Could you summarize?
Yes, so the question is, I guess the summary, correct me if I'm wrong, is that when you call L dot backward, what's happening? And the answer is whatever function you've had, whatever computation that you have done up to that point, when you call backward, Torch with its magic computes the gradient of that value with respect to all the variables that were involved up to that point for that computation. And I think the point that you were confused about, where is it in this? Oh, was this, right? Yeah. When it does compute the gradients, it stores the gradient of each variable in this grad member of that variable.
So what if now I define another function, loss1,
Okay.
and I do loss1 dot backward? That also depends on the variable W. So when I do W dot grad, grad will be confused. Is this a gradient with respect to this function L or this new function
I
loss1?
think what happens, correct me anyone if I'm wrong, is that it will, so you have already called backward for L, and then you call backward for F. I think Torch will automatically sum the new gradient from F with what you had from doing backward on L. Yeah, that I think. And that's why you have to call 0 here.
Yeah, until you flush out. Yeah, 0.
Yeah.
Do it and see for yourself. It takes you
said that.
10 seconds.
I mean, all these questions, I understand that I can do in an answer, but I think I'm more confused on what's the logic behind this. How like you write the things in Torch, and I think that global answer will be useful to me. I can do that.
Sure. She has a question regarding the 0. You want to ask?
Oh, so it's basically why do we have to manually zero out the gradients?
So there are some applications when you actually call backward multiple times and you want to accumulate your gradients before you take one gradient step. So this allows you, so if the gradient was zeroed after each backward, sort of after each step automatically, you won't have that freedom. So you want to be able to accumulate gradients and then zero them whenever you want. That's sort of how Torch is designed to give you that capability.
Set the gradient for each sample, right? The x data, right? For x value.
For each time you have calculated your forward function, it could be multiple samples, it could be a batch.
Each sample will set this.
All right.
Thank you. So, can I have that thing?
Oh.
Thank you, Sia. And thank you, Werner. Everyone else. So now the ending. What to do next, and what is important. And I'm interested in doing stuff and learning more. Now, where should I go next? So you remember that Chinese proverb that if you want to feed someone for one day, do that. So here uh, we have we have tried to teach you fishing, which is the ultimate thing that you need. And now you have all the tools that you need to make yourself comfortable with what is going on in the back. Hopefully, you have discovered the usefulness of the deep learning book, which is freely available online. You have learned how to use the collab, and you have seen how to go and look things up around the topics that you're interested in. And now things are less magical and foreign to you because you know islands in the area of deep learning. All right. So the next logical step for you would be to start expanding your island, and then you will see that after a while these isolated islands start merging together, and then you will have this really useful and vast information and knowledge about what to do with deep learning and how to use it, and you'll start applying it to real problems. So what to do now is to continue reading the deep learning book. It will take you about a month to read because I'm sure you have jobs, all of you, or you have lives. And possibly both, but there is. And then, so it will take you, hopefully, at least one of them. So, what? So keep reading that book, and then on the side start learning PyTorch. Go through the PyTorch is the best documented piece of software, one of the best. So you have lots of good tutorials, lots of good articles on Medium and Data Science Central and everywhere else. Start learning about it. If you're interested in the NLP applications of deep learning, look up the Stanford course on NLP and deep learning. Their new version came out a couple months ago, and it has the full thing, and it's based on PyTorch, and it's good.
Who teaches the new one? Chris Manning or socials? Or
Manning.
Manning?
Yeah. And so look up that one. It's particularly about deep learning for NLP, if you're interested in that, and then do the blog thing that gives you another opportunity to read. And something I wanted to tell you is that, look, you don't need AWS and GPUs and a lot of money and a PhD to do deep learning. And you don't need to go to many different classes and courses and certificates to do deep learning. You have everything you need now. And what I showed you here, all the examples, I did it on my Chromebook that I got it for my birthday. Like it cost $300 only, and I ran everything on Colab for free, and that's it. That's what you need if you really want to learn deep learning. Now, when you get to the stage where you have tons of data and you have to run experiments, and that's a separate issue. That's a separate story. But to get there, you need months of access to free stuff. And everything that we have shown here and we have talked about here and we have discussed, everything is free. So basically, you can learn deep learning without spending money on that. Then if there are areas that you're super interested in and you want to go deeper and you really need a mentor for that, then you can pay for that. And there are many areas that we did not cover here. So our workshop is ending, but we are just at the beginning of mathematics of deep learning and deep learning itself. And we didn't teach deep learning, by the way, here. We talked about mathematics of deep learning. If there are areas that you're interested in, talk to Amir. He can set up workshops on other aspects and different aspects of it. And let's stay connected. If you're adding me on LinkedIn, please mention who you are, because sometimes you don't have pictures, or your pictures are taken at a different time and a different angle. And so I need to know who you are if you're connecting on LinkedIn. I hope you have had fun. We spent 9 hours together, and I hope this is the beginning of your career with deep learning. Thank you.